Hey everybody, it's the day before Thanksgiving break starts. This is 15.6 flux we're working on. These are the equations we've been using. F dot NDS kind of covers them all because the gradient of G and RU cross RV fall under the category of N. But it's easier to sometimes remember them when you see the different things. Like if G is the gradient of G is if we have something where we have Z as a function of X, Y, X is a function of Y, Z, or Y is a function of X, Z. Those are the times to use this. N is kind of like when you know the normal vector for the surface you're working on, it doesn't change, just handy. And RU cross RV is when you need to parameterize because it's an ugly surface and it's easier with the parameter. Thanksgiving is Thursday. We do have Wednesday off as well, so there will be no classes tomorrow. I will be at Starbucks Wednesday morning, Friday, Saturday, Sunday morning. If anybody lets me know they want to go, from 8 to 11. I'd rather volunteer my time to keep you guys on task, and that way you guys get to this class not with an A, which is what you guys, most of you are aiming for, but with the knowledge that you're going to thrive in the future. And so I'm doing that. If you guys want to come, let me know. If no one messages me, I'm not. I'll stay home and play Neo. That's the game I'm playing right now. So those are our functions there. Let's take a look at our first problem. So what's the first thing we should probably do? I didn't hear you. What'd you say?
No, I was just talking about our test yesterday. CSI.
Yeah, Lawrence, when are you going to talk about calculus?
Paraboid is kind of opens like that.
Sure, this is about as big as my class in gifts. From 8 students, not counting.
Are you going to be the diff SI next?
No, actually, you know it. Yeah, actually I do. It's other Brandon. So we have 2 Brandons including me. There's 2 Brandons in my gifts class, and so I'm Brandon 1 and he's Brandon 2.
I did get on this.
It's an inside joke, but
you name yourself Brandon 1?
No, someone else named me Brandon.
So we got a paraboloid going up.
Yeah, it's another Brandon that's in this.
And we project it down. We got a circle in the XY plane.
He's talking about after calculation.
And it said N is oriented negatively. So we're having downward stuff for N. Which means, like, which format do we want to use? I mean, N here, we can do F dot N. We can do F dot grad G, which is probably the best way to go because we've got Z as a function of the other two. Or we could parameterize it. If we're going to go with grad G, what I failed to mention earlier, and I probably should have, grad G implies positive orientation. So if we're going to use it and it's not positive orientation, it's downward, it's negative, we should use negative grad G for this problem. So maybe negative grad G would be better usage since we have downward normal units. So regular grad G is when we have Z, it's negative ZX, negative ZY, 1. Oops. I need to put this underneath there. Give me a second. There we go. Surface so it doesn't spin. There we go. Perfect. So if we want negative grad G, derivative Z with respect to X is 2X. The negative, these two negatives will cancel, just be the 2X. The derivative of Z with respect to Y is 2Y. The negative there and that negative will cancel. That'll make that 2Y. And this one gets hit by that negative, we got negative 1. So we're doing dotting F with our normal vector. We're going to have a dA here at the end because we're doing del G or grad G. We are dotting 0, Y, and 1 with 2X, 2Y, and negative 1. And we've got dx, dy. I'll just put dA because I don't know what order we want to do it in yet. And so it looks like our surface integral boils down to 2y squared minus 1 dA. Now we are in terms of x and y. So our surface is in the xy plane. And in the xy plane, we have x squared plus y squared equals what? It's a projection from the very top, z equals 4. So if I plug in 4 to my equation, I have x squared plus y squared equals 4. Bless you. So we can stick with dx and dy if we like to suffer and like to work with radical signs. I'm not a big fan of doing that myself. So I would rather switch to polar. Polar, we would have 0 is less than r less than 2. 0 is less than theta less than 2 pi. And the only thing we got to remember is that our conversion comparison, y is r sine theta. And I'll write it just, we don't need it here, but x is r sine theta or r cosine theta. You've seen that in 5 different semesters of mathematics. Hopefully one of these days it will stick. It didn't stick on this last test for some people. That's why I'm bringing it up. Let's see. So we've got 2 times y squared. So 2r squared sine squared. And then I've got my minus 1. That's good to go as is. And I didn't square that. And then our dA is, don't forget the correction factor, r. So r d theta. All right, so what is that when we clean it up? 0 to 2 pi, 0 to 2. I've got 2r cubed sine squared minus r dr d theta. So we integrate. We got 1/2 r to the 4th sine squared theta minus 1/2 r squared, going from 0 to 2 d theta. So I stick in 2, I got 16 for r to the 4th. Divided by 2 gives me 8 sine squared theta minus r to the 4th would be 2, 4, and then I got an r out front for some reason. That's a 2. 4 over 2 is 2 theta. All right, so now we got a sine squared. Some more trick stuff that you are more likely to have forgotten than this is the variance of cosine 2 theta. Cosine 2 theta comes in handy when we have squared stuff. There's 3 forms: cosine squared theta minus sine squared theta, 2 cosine squared theta minus 1, or 1 minus 2 sine squared theta. That last one's looking like the one I want to use. So I need to get 2 sine squared theta by itself. I'll subtract the 1 over. And then divide by or multiply by -1/2. Which means 1/2 minus 1/2 cosine 2 theta. That's what sine squared equals. Okay. So 8 times 1/2 is 4. So this ends up being 4 minus 4 cosine squared. Not cosine squared, cosine 2 theta. Minus 2. So that cleans up to 4 minus 2 is 2. 2 minus 4 cosine 2 theta d theta. Now the cosine 2 theta, we're going from 0 to 2 pi. And so when we have that periodic function and we're getting right back to the same spot we were on it, it's magically delicious. That goes away. And all we're left with is 2 theta from 0 to 2. That's right. What is that, Lucky Charms? Do they still make those commercials? Have you guys watched commercials in your lifetime? You guys are so young. Streaming's been around forever.
No, we're
like full blown commercial at this point.
we're old enough that we've watched TV and seen the commercials.
I think the ratio.
I'm gonna probably unload a clip into my head when my students don't know what a commercial is, because all they've ever had is streaming. You're too old.
Well, they'll call it. You know what? They won't call it a commercial. They'll call it ads, because that's what people would call them now. I could definitely see. That's where you should be.
That's fine. If yeah.
Because that
So
means that they're not watching TV anymore. And frankly, they're not actually.
Yeah, what is the?
You guys don't watch Netflix or Hulu or anything like that.
I
Bullshit lies. You may not, Brandon, because you live under a rock.
Okay, well, I don't watch a lot of the shows. I just use a different streaming service. That's all.
So, but you're still streaming something that's visually displayed on a monitor or a laptop or a phone or a fucking some sort of screen. You're still watching TV. Just because it's not on a television doesn't mean it's not TV. Right.
Or record something in advance.
Any questions on that one? All right. So let's move that to the side. I'll do the next one. I got two more I want to do today. To make sure we do them, I want to set up the first one and then set up the second one. We'll choose which one we want to go through do the integration if we run out of time. Yeah, this looks like a good one to start with.
You got a variable. Okay. Okay.
I don't think we need a unit normal. That isn't necessary. We just in the positive direction will work.
Yeah, I mean it's got. You mind bringing up that whiteboard if you still have it with all the equations?
I just wrote it on the board if you want to take, if you need to take it away.
Okay. Giving people a chance to look at it and write it down. Well, maybe the first thing we should do is maybe draw a picture. Let's get a feel for what we're looking at. Now, some of you are going to say, I don't know how to graph 6x plus 3y plus 2z equals 6. And for that, I say, bullshit. You just haven't done it so long, you don't recall doing it. Set two variables equal to 0 and rule. So if y and z equals 0, I get 6x equals 6. So x equals 1. And I get the coordinate 1, 0, 0. If I set x and y equal to 0, I'm left with my z's. I have 2z equals 6. So z equals 3. And when x and z equal 0, we have 3y equals 6. So y equals 2 when x and z are 0. And so that gets us the point 0, 0 or 0, 2, 0. So my surface is this.
Someone like that.
Yeah, planes are probably the easiest thing to draw in 3D. All you have to draw is
Right. And it's in the first octant, so that's actually the full surface. That is the full surface. If we want to project it onto a plane, the easiest choice would be to project it onto the XY plane. So if I look at that XY plane, I have a 1 and then a 2. This is the XY plane. So I've got y equals rise over run is -1/2 x plus 2. That's that line right there. That'll probably come in handy when we're doing boundaries. Clearly, we don't want to switch to polar or anything like that because it's not round. So we know what we're looking at. So if we're wanting to project it onto the XY plane, we're wanting to deal with Z. So maybe let's solve the surface for Z. If I do that, I've got 2Z equals 6 minus 6x plus minus 3. And so Z equals, if I put them in order, -3x when I divide by 2, minus 3/2 y, plus 3. Which makes getting grad G handy. It is positive orientation, so I just recall this is -zx, -zy, and 1. So the derivative of z with respect to x is -3, but we're making it negative, so that's +3. Derivative of z with respect to y is -3/2. We're doing the opposite sign, so +3/2. And we've just got the 1. So that's my grad G. So we're going to do f dot g, or grad G, x squared yx z. I think that's supposed to be a zx. Let me go look. What problem did I take this from?
Are you sure you didn't accidentally just put a K then? K in.
It's zx. It's right there.
Oh, okay. Oh, so you wrote the K instead.
Yeah, that should be a zx. Sorry.
All right.
Got
Yeah,
it.
except for that X instead of K, or K instead of X.
Yeah, we have a change up here. Zx, not zk. It doesn't make sense to have the k there because we've already got it in the vector arrow notation. So f dot g grad G is 3x squared plus 3/2 xy plus xz. Since I've already got this listed in terms of y, I'm going to do y first. So y will go from 0 to -1/2 x squared plus 2, which means my x is going from 0 to 1. And then we got dy dx.
Yes, question?
How did it go from 3x squared plus 3xy plus okay, how did it go from 3 halves xy to right, it makes sense.
Yeah, as soon as you said it, I realized I done fucked something up. I added an extra square. Sorry, Andrew.
Yes.
All right, so
We're gonna replace z.
we can do this, and we got time to set up the other problem and go through it. So let's just finish.
What are we gonna do
Z,
about?
what is Z? We need to deal with Z. What is Z here?
It's gonna be a function of x and y, probably.
Right, we have Z up here. We solve Z right there. So I gotta put my Z in. Ugly. Ugly.
I mean, they will cancel out.
And now we've got our dy dx. Oh god, that got uglier. It's just some cleanup. Let's do some cleanup. I think some shit goes away. Look at this. I think some shit goes away. So when I distribute this, I get negative. This becomes, I'll do it in red. This is negative 3x squared. This is negative 3 halves xy. And this is plus 3x. So when I clean all that crap up, the 3x squared minus 3x squared, that goes away. The 3 halves xy minus 3 halves xy, that goes away. And all I'm left with is 3x. Holy shit, that cleaned up nice.
Almost like they.
It's like it was tailored to do. Don't anticipate this on your test.
Oh, so don't expect that the test will have textbook problems on there.
So
No.
happens like.
I model my stuff after textbooks problems, but I try to avoid using textbooks problems. I alter the numbers. I will make sure they work out fine this time. The reason why I do that is because I don't want people are slick. I've had someone cheat 7 or 8 feet away from me, and I knew she was a cheater, so I made her sit up front, and she still fucking cheated. And I don't know how she did it because I was watching her. So rather than having something that you could Google, because I know Chegg and other things show answer keys to textbooks.
How do you know she cheated? If you didn't.
It was obvious. It was an algebra class, and she skipped way too many steps. And she didn't have that skill. She admitted it too. After I confronted her about it.
Probably like become this part.
All right. So we integrate this. Now I wish I had done the dx first. Oh well, fuck it. I don't want to reset up the problem. We got 0 to 1. 3xy evaluated from 0 to negative 1/2 x plus 2 dx. The 0 part goes away, and we have negative 3 halves x squared plus 6x.
Oh. So yeah, you was actually your parents.
So what I did there was 3x times negative 1/2 x plus 2. Bink. Bunk. Bunk. All right, we integrate this up the power, divide by the power. I got negative 1/2 x cubed plus 3x squared. And we're evaluating that from 0 to 1. Negative 1/2 plus 3.
Math is wrong. Their math is wrong. Their math is wrong. Oh, what the hell is that? Yo, you should. Yeah.
you know, I remember my geometry teacher like, oh yeah, we don't use these mixed numbers, we use them. Like, what? What are you talking about?
Geometry?
Yeah, in geometry in high school. And they're like, and now like, mixed numbers? Mixed numbers? I mean,
How many people are there, Brandon?
we have 7 students, not counting me.
So the standard 7.
The standard 7.
Let me
Minus
guess,
check.
because I can't see everybody there. Let's see. The students that do the best show up all the time. There's gonna be Eric, Lawrence, Ben, James, of course. I know Andrew's there. There's 2 more. Who else is missing? Let me think.
He's trying to figure out who's actually here.
Chris?
without actually-
Is Chris there? I don't know everybody. You guys are in a little tiny window on my screen, so I don't know who's there. Who else is there? I named 5 of you.
You forgot about Carlos.
Oh, Carlos. Yeah, how did I forget Carlos?
I don't know.
Why is that?
So who's the 7th?
Angel.
Oh, I see what you're saying.
Oh, Angel. Yeah, I heard a female walk in. Angel. Angel's an attentive student. There we go. He likes to come in and get stuff done. You guys ready for the harder one?
Very first
Um,
class, it was like,
Mr. Jones, I'm sorry to break this to you, but Eric found a fault in your graph. In one of your pals.
It's James.
It's James.
What's wrong with my math?
Eric said that it's saying that y equals negative 2x instead of plus 2 instead of negative 1/2 x.
It is definitely negative. It's a descending line.
Yeah. But he's saying it's 2x instead of 1/2 x.
It is not 2x. 2x would be like this. That's y equals 2x. So 2x
No,
plus
negative
2 would
2x.
be up there.
No, he means negative 2x. Sorry.
Okay. Oh, shit. You're right. That is negative 2x, isn't it? Oh, well, fuck it. I'm not doing the rest of the problem over again. That just changes this right here. You know what? Oh, well, it's too late. That changes all those, and it changes everything after it. Actually, it doesn't change that much. Let's fix it. Good catch. That just changes this shit. Good catch. That is negative 2x. Son of a bitch. I hate when I do stupid shit. All right, so I've got 3x times that. I've got negative 6x squared plus 6x dx. Doesn't change too much, does it? Just change the very end. So we've got negative 2x cubed plus 3x squared from 0 to 1 gives us 1. That was a quick fix. Good catch. Well done, sir.
Well, don't point to me. Eric's the one that keeps catching your problems.
That's who I was talking to.
I'm so blind, only me.
Eric is right. That is not 1/2 x squared, negative 1/2 x squared. That is negative 2x plus 2. Where did I say square? I keep throwing in squared for no reason. Just stop talking, Dave.
Probably because he probably reversed it. Like that. Probably it might have been like negative 1/2 y though. If it was a
Oh, yeah, you went down 1 and over.
yeah.
Instead of down 2.
Yeah, I rushed it. And then that way I did run over rise rather than rise over run. All right, let's do the other one. You got to do your grad G. Let's do some RU cross RB.
Hey, why don't we check our answer in the back of the book?
No.
I'm checking answers in the back of the book because the back of the book half the time, well, not half the time, but isn't always right. I want to say at least 10% of the time they're wrong.
10%.
Maybe not 10%. They're wrong often enough. So this
Hey, you were
looks
right.
like we've got some elliptical spiral. It looks like this looks like this is doing something like this.
Relax there. I'm trying to write.
It was a spring.
Strength boy.
I was just discussing what R looked like. I haven't done anything else. We don't need the picture because we have R and we have F. So I know you have it on your screen over there, but we're looking at F dotted with dr du cross dr dv, which means we need to find dr du, we need to find dr dv, we need to cross them, we need to dot them with F, do a little happy dance, and go have Thanksgiving.
You know, cross our U's and dot our V's.
Yes, cross right using daughter V's. So let's see, we got dr du. Oh shit, that I'll do that one. You guys do the other one.
Is it a team effort?
Yeah, I'll do the hard one. You guys do the other one.
I expect mine to be right.
It's okay, it's your notes.
So we want those two crossed. I don't need to write so big. What are you doing? We got -2 sine V. So RU cross RB.
It's like, yeah, I think it works both ways. You do it one and do the other way. It's like, that's the wrong way. You get it wrong.
That minus that, I got negative cosine B. For J, we got that minus that, which would be 2 sine B, but J is negative. So that should be -2 sine B. And K is 0.
Then there were 6.
Wait, shouldn't that be positive 2 times? 0 minus, oh, hang on.
Did I get that right?
Yeah.
It's not, that one's not mistaken for a T.
Yeah.
What? There's no T in this problem.
I was joking.
So we have negative e to the negative y cosine v, 2y sine v, and 0 when we dot those. Now, we've got y's and v's together here. We don't want that. So what is y in this problem? That is not a vector. That is addition. We don't want that. So what is y in this problem? Well, this is x, y, and z. So y is sine v from R, which means this is negative e to the negative sine v cosine v plus 2 sine squared v.
Natural log. Like taking natural log.
Oh, taking the natural log. I thought you said take a nap.
I don't want to take the natural log.
Oh, that sounds.
Natural log of 2 sine squared v.
Why? When a u sub will work or a w sub.
I just see an E and I'm like, I feel it.
He's very
Zero.
prejudiced against these.
0 to 2
He's
pi.
very much a natural log supremacist.
I've got 2 sine squared v minus cosine v e to the negative sine v. And
No,
we're
that was
doing dv du.
Gonna be by John Blake.
Gosh.
So I'm going to break this up into 2. Because how I handle each piece is different.
I was gonna take natural log.
No, it's not. Sure, you love Jeff said. You do that a lot.
So I'm going to say this part comes down easy. So let's just talk about what's going on here. I'm going to say W equals, I'm going to get rid of the negative at the same time. I'm going to say negative sine B. So that dW is negative cosine B dV. And so I've got the negative here and I've got the cosine B there. This part on the right is just going to shift into, oh wait, limits of integration. When B is 0, W is 0. And when B is 2 pi, oh, look at that. Isn't that beautiful? W is 0 as well. So this entire thing goes from 0 to 0, and that's a dead integral. It's a dead integral.
Maybe it was E's fault. I bet that's what Lawrence is thinking. We have to destroy all these.
So all we have left is this integral on the left. And we got done earlier showing.
Like if I did this on a test and I just saw it say went to 0 to 0, I'm like, there's no way it just dies.
No, we have the 2. It's just 1 minus cosine 2 theta.
Although I would be more scared if the entire integral went to 0 and I just had 0 theta. So
You should always try to do the easiest thing first. U subs are definitely easier than thinking about integral or natural logs and shit like that. Because if you take the natural log, you have to hit everything with the natural log. And that's some messy, that's some bad juju right there. But this isn't too bad because again, when we do oh, why do I have d theta? Why do I have theta at all? This is v.
You're probably thinking of your triggered entities, and that was what the first thing that popped in your head.
Yep. So cosine 2v, when we integrate it, it's going to get killed by the 0 to 2 pi. So I have 0 to 5 v from 0 to 2 pi du. 0 to 5 2 pi du.
Oh. 10 pi. Or in other words, 10 double tau.
That is what? Get out. You're fired. That doesn't look like tau at all. Tau is like that.
What? Don't worry about the
Maybe-
details.
Maybe if I wrote my pi like that, I could see the double tau.
That's one cool with pi.
Actually, frankly, I tend to do my pi kind of like this.
Look at that. I picked the perfect amount of work. There's 3 minutes left. Just enough time to wrap things up. If I do not see you over what?
No, I was saying I can actually draw my pies like yours, like that last one. With a little curly top.
Yeah, I usually do. Every once in a while I'm lazy. Notice it's kind of got a flat top right here. But when I've got room to write, I like the little wave. So if I do not see you over Thanksgiving break, because you don't want to come to Starbucks, have a great Thanksgiving, everybody. If you do, let me know on Discord. Or email me or something. Wednesday, Friday, Saturday, or Sunday morning. Any of those mornings are open for business.
Right. Enjoy your streaming services and definitely not TV.
Hell no.
Eh,
No, I'll be doing cocaine and calculus.
Oh, no. You mean you're CNC?
Try to do good.
Yeah.
Yes, sir.
Oh, man.
And Ben was.
Right. All I have is a lab and a DIPS exam. Woo! But
Today?
yeah,
Oh, good luck.
thank you.
Just what?
I have a differential equations exam today.
How's your fun though? How many exams did you give?
Let's see. I think this one's exam 4 and